Hi guys, today I'll be teaching you how to solve the limit of a trigonometric function through a step-by-step process. We have here our problem. The limit as x approaches 0 of sine 4x over or divided by 3 sine x. For our step number 1, check for indeterminate form. We can try direct substitution or just plugging in the value of x into our expression. We then have sine 4 times 0 over 3 sine 0. And the answer is 0 over 0 or an indeterminate form. So we need to use trigonometric identities or special limit rules to solve our problem. And that's for our step number 2. Use the fundamental trigonometric limit. So the most efficient way to solve this is using the standard limit property. The limit as theta approaches 0 of sine theta over theta equals 1. To use this, we want to manipulate our expression so that every sine theta has the same theta underneath it. And we will now start solving in our step number 3, or the algebraic manipulation. We can rewrite the original expression by multiplying the numerator and denominator by terms that helps us reach the standard form. So to break it down, I will put it into 3 another steps. So first is to isolate the constants. We can pull the 3 out of our limit. So this will give us 1/3 times the limit as x approaches 0 of sine 4x over sine x. And for our second step, for our step number 3, we can multiply it by creative forms of 1. So we need 4x under the sine 4x, as we mentioned here in our step number 2. And we also need x above the sine x over here. And this will give us 1/3 times the limit as x approaches 0 of sine 4x over 4x times x over sine x times 4x over x. Then we will now move on to simplifying our terms. We can notice here that our variables 4x over x can be cancelled out, leaving us 4. So this gives us 1/3 times 4 times the limit as x approaches 0 of sine 4x over 4x times x over sine x. And for our last step is applying the limit. We can now apply the limit property to each part. The limit as x approaches 0 of sine 4x over 4x is equals to 1, as we mentioned here. And our expression here, x over sine x, is also equals to 1. Note that this is just a reciprocal of the standard limit. That's why we will still have the same answer, which is this, 1. So we can now substitute our values back into the equation. We can have, so we will have 4 over 3 times 1 times 1. We had here our 4 over 3 since we can multiply these terms by just itself. And our final answer will be 4 over 3. So the limit as x approaches 0 of sine 4x over 3 sine x is 4 over 3. And that's how you solve a limit of a trigonometric function.
Good day, everyone. Today, I will explain how to find the limit of the given function. We are asked to find the limit as x approaches 3 of the expression x squared minus 4x plus 4 over x squared minus 9. To solve this problem or the given function, I prepared here a 8-step process. The first step is we factor both the numerator and denominator. The numerator x squared minus 4x plus 4 factors into x minus 2 squared. The denominator x squared minus 9 factors into x minus 3 and x plus 3. So that we come up with the result of x minus 2 squared over x minus 3 and x plus 3. Next, we check if there are common factors that can be cancelled. So there are none, so the expression cannot be simplified further. This means x equals 3 remain in the denominator. Now, let us try direct substitution. If we substitute x equals 3, the numerator becomes 1, while the denominator becomes 0. Since division by 0 is undefined, we cannot evaluate the limit directly. Because of this, we analyze the behavior of the function as x gets closer to 3. The next step is to analyze the numerator. The numerator x minus 2 squared is always positive and stay close to 1 when x is near 3. So now, let's proceed to step 5. Let's analyze the denominator. The denominator is x minus 3 and x plus 3. The factor x plus 3 is close to 6 and it's positive. So the sign of the denominator depends on the factor x minus 3. So the step 6 is left-hand limit. When x approaches 3 from the left, x minus 3 is negative. This makes the denominator a small negative number. A positive number divided by a small negative number results in a very large negative value. So the left-hand limit approaches negative infinity. So now, let's proceed to step number 7, the right-hand limit. When x approaches 3 from the right, x minus 3 is negative. This makes the denominator a small positive number. A positive number divided by small positive number results in very large positive value. So the right-hand limit approaches positive infinity. Since the left and right-hand limit are not equal, therefore the final conclusion is that the limit does not exist.